Hai, selamat tengah hari. Selamat sejahtera. Okay, our assignment name is Force and Factor of Safety Analysis from Actual Structure. My name is Hitira Nalaki Militaran dari BMKA 1/1. So, I as a team leader uh, going to present you about our process of the assignment. Okay, first of all, the introduction of our assignment is the assignment provides a structured process. Student must photograph three structure process, propose one approval, idealize and model it, make assumption and produce free body diagrams and equilibrium equation. They will then analyze mechanical force and reaction and calculate the factor of safety. Ultimately, this assignment offers a comprehension learning experience that strengthens core concepts of solid mechanics while also developing critical thinking, problem solving, reporting, and collaboration skills. Through this hands-on engagement with real structures, students gain valuable insight into material behavior and structural analysis that will benefit them in their future engineering career. For this assignment, our free body diagram is a, is a canopy, how to say bumbung, how it's stable and everything about that. Uh, Cons and this one. So these are our assignment.
Literature review. Engineering analysis of structures, particularly in solid mechanics, relies heavily on empirical data and established principles concerning stress distribution and material behavior. Understanding the typical uses and configurations of gantry-style overhead support structures is crucial, with literature highlighting truss systems for efficient load transfer and high strength-to-weight ratios. Material section, often involving steel or aluminum alloys, plays a key role due to properties like yield strength, tensile strength, and Young modulus, which influence structural performance under load. A thorough review of material science sources also addresses factors like corrosion, fatigue, and environmental effects. Solid mechanics fundamentals, stress, strain, and equilibrium equations like Fx equal to 0, F4 equal to 0, or moment are applied using standard modeling and analysis methods to develop accurate free body diagrams and predict internal forces. Literature further supports identifying potential failure modes and determining appropriate safety factors, which are essential to account for uncertainties in materials, loading, and fabrication. By comparing our analysis with industry standards and case studies, we ensure the chosen structures' reliability, structural integrity, and long-term performance. Alright, for the methodology, the first thing we did was calculate all the forces on the joint and moment for joint A, joint B, joint C, joint D, and joint F. After that, we made a conclusion that since the truss is symmetrical, the same force occurred on the other half of the truss. The last thing we did is find max allowable force and factor of safety. The max force from the calculation is 11.01 kilonewton. After we done some research, this is our research information for the web height, flange, width, thickness, and material. Material use galvanized steel. For the factor of safety, target factor of safety is 2, equal to. So after I've done the calculation, max force is 11.01 kilonewton and max allowable force is 15.5 kilonewton. So it is safe.
Assalamualaikum. My name is Abdul Halim. The discussion of the assignment is the analysis of the selected gantry style overhead support structure. Use a systematic approach to understand its behavior under load. It begins with the creation of free body diagrams for key components. such as the horizontal thrust and vertical support to identify our acting force. Using this diagram, static equilibrium equation is Fx equals 0, Fy equals 0, M equals 0 are applied to calculate unknown support reaction and internal force like axial, shear, and bending moments. Material properties such as yield strength, tensile strength, and Young modulus along with estimate cross-sectional areas are used to determine normal, norm, determine normal and yield stress in critical members. The most stress components are then assessed for possible failure by comparing stress level to material limits. A factor of safety (FOS) is calculated to evaluate structural safety, identify weak points, and estimate the maximum allowable load. This complete process ensures a reliable understand of load distribution, internal stress, and overall structural integrity. For the last is conclusion. These experiments help us better understand how the Grand Tree-style overhead support structure behaves under load. By using solid mechanics principles like free body diagram (FBD) and equilibrium equation, we were able to find both the external force and the internal force in the truss and support members. We also calculated the stress in important parts of the structure and compared them with the material's strength to check if it's safe. We determined the maximum load the structure can handle and calculated the factor of safety to measure its safety margin. Overall, the study shows how solid mechanics theory can be applied to solve real engineering problems, meeting the goals of analyzing force members, finding the allowable load, and checking the structure's safety.
And for the reference, we also take this for from this for this one, analyzing the using of method of joint, then roof trusses, structural and cost benefits all. So these are from our all over the assignment. So thank you so much as a team leader. I conclude this and thank you so much.